In this video, we are going to look at constructive and destructive interference. So let's first look at constructive interference. We have got wave 1, which has an amplitude of 5, wave 2, which has an amplitude of 3. Both 5 and 3 are in centimeter. If you look at the axis, the unit is labeled. Now, if you want to add them, we can see that both of them have positive amplitude. So when you add, the resultant amplitude will be 5 plus 3, which is equal to 8 centimeter. Now if you want to draw the resultant wave, we will take the same axis and then we will label where is 8 centimeter. So the resultant wave will look like this. So we can see that this is our resultant wave, whereas previously what we saw, I will show you, this is our initial wave 1 and wave 2. So when you combine these two, you are going to get the resultant wave, which will look like this. Next, let's look at destructive interference. When will destructive interference take place? Now look at destructive interference. For destructive interference, we require one wave with positive amplitude and one wave with negative amplitude. So we can see that wave 2 now is having negative 3, and when we add these two waves, we need to take the negative sign. So resultant amplitude will be 5 minus 3, which is equal to 2 centimeter. So this is wave 1 and wave 2. They are undergoing destructive interference, and when we draw the resultant wave, it will look like this. So you have got 2 centimeter, so plus 2 centimeter, you can see that the wave has become smaller. Another way of having destructive interference is when the two waves are traveling towards each other. One of them is having 1 centimeter amplitude, the other is having negative 2 centimeter amplitude. So the waves are moving towards each other, and we want to know what will be the resultant wave. So the resultant amplitude will be 1 minus 2, which is minus 1 centimeter. And if we want to draw it on the graph grid, we will find out where is minus 1 centimeter and then draw the wave, which will be the resultant wave. So this is an example of destructive interference, because one wave had positive amplitude, another wave had negative amplitude. Similarly, we can have constructive interference for the two waves traveling towards each other. Here we can see one is having 1 centimeter and the other one is having 2 centimeters. So the resultant amplitude will be 1 plus 2, which is 3 centimeter. And if you want to draw the resultant wave, it will look like this. Resultant wave with 3 centimeter amplitude. Next, standing waves. Now, interference can give rise to standing waves when the two waves are traveling towards each other and they are having the same amplitude, they are traveling through the same medium and same frequency. So the standing waves would look like this. One of the standing waves can look like this. So here our objective is to find where is the node and where is the antinode. So nodes are these positions which I have labeled. These are the points which are not moving up or down. These are called as nodes, and we can label them as N. And in between the two nodes, you can see there is an antinode, and there the particle is moving up and down. This is called as antinode, and we can represent it with letter A. So if you want to count the number of nodes, it is 3, and number of antinodes, it's 2.